Hey everyone, welcome back. This is going to be a free response questions overview walkthrough of the Unit 1 limits test for calculus. This is going to be the two questions at the end of that review. If you haven't seen my multiple choice questions review, you can check that out in the other video that I posted as well. But let's get into the free response questions. So here we're given the function f of x. We know it's x cubed plus 2x squared minus 3x over 3x squared plus 3x minus 6. We want to know what are the zeros of f of x. So with zeros, we're setting our function equal to 0. So x cubed plus 2x squared minus 3x all over 3x squared plus 3x minus 6 equals 0. Well, if I want to start solving for this, I can just multiply this denominator on both sides. And since I'm multiplying into 0, it's just going to just disappear. So we can say, all right, now I have x cubed plus 2x squared minus 3x is now equal to 0. What I notice here is I can factor. So I can factor an x out, and I have x squared plus 2x squared minus 3 equals 0. And then I have this quadratic. Actually, this shouldn't be squared. That should just be 2x. Now I have this quadratic x squared plus 2x minus 3. And this can be factored. Two values that multiply to be negative 3 that combine to be positive 2. Well, that's going to be x plus 3 and x minus 1. Now those are still all equal to 0. So I actually have 1, 2, 3 zeros. I just need to solve for each of these. So x equal to 0. X equal, well, x plus 3, subtract 3. That's going to be x equal to negative 3. And x equal to, we'll add 1. So x equal to 1. Those are going to be all three of the zeros for this question. You do have to show your work on all free response questions. But this is enough that we can go off of and get full points for part A. What are the vertical asymptotes of f of x? Well, for vertical asymptotes, we're looking where is that denominator equal to 0. So 3x squared plus 3x minus 6 equals 0. Okay. We're going to come back and we're going to look at it because where the numerator has similar factors, if they're dividing out, they're not vertical asymptotes, they're removable discontinuities. But I do want to say, all right, where is this going to be 0? And that's going to give us possible vertical asymptotes. What I notice here in this quadratic equation is I could factor out a 3 first. X squared plus x minus 2. And then we're looking for two values that multiply to be negative 2 and combine to be positive 1. So we're in a 3 x plus 2 and x minus 1. So now I'm going to write this over the factors that I got in part A. X plus 3, x minus 1 over 3 x plus 2, x minus 1. And what I notice here is that those x minus 1s are the same. So those are going to divide out. And so really all I have to do is take this x plus 2, set that equal to 0, x equals negative 2. This is where we're going to have a vertical asymptote. The end behavior model of f of x is the function g of x. What is g of x? So let's look here at this end behavior model. When I'm thinking of end behavior, I'm thinking of limits that approach infinity. So the limit of, and let's go back up to our function. Let's see, that was the limit of x cubed plus 2x squared minus 3x over 3x squared plus 3x minus 6 as x approaches infinity. So we're going to want to come over here and jump into some long division. What we can do actually is take some of the factors out and just use these x squared plus 3x over 3x plus 6. So I'm getting that from right here with the factors taking out the x minus 1 factors dividing out. We're going to jump into this long division, this 3x plus 6, okay, and then we have x squared plus 3x plus 0. All right, so 3x plus 6. 3x times what gets me x squared? That'll get me 1/3 x. That's what I need to multiply by. And then distribute 1/3 x times 3x. That's going to get me x squared. 1/3 x times 6 will get me 2x. And then just subtract. So those cancel out. 3x minus 2x is x. And then plus 0, could bring that 0 down. And we just ask ourselves, 3x times what gets me x, so plus 1/3. And 1/3 distributed across everything. 1/3 times 3x is x, and 1/3 times 6 is 2. And you just subtract again, so we're going to get -2 for our remainder. But this right here, that is g of x. So g of x is equal to 1/3 x plus 1/3. And now we're going to use that result in part D. What is the limit of f of x as x approaches infinity? What is the limit of f of x as x approaches, what is the limit as x approaches infinity of f of x over g of x? So the first one, f of x is going to infinity. So the limit of f of x as x approaches infinity is equal to infinity because the numerator is larger. Now here we have f of x and g of x, so we're going to take f of x, which is x squared plus x cubed plus 2x squared minus 3x divided by 3x squared plus 3x minus 6 all over g of x, which is 1/3 x plus 1/3. And we're going to multiply by the reciprocal. X cubed plus 2x squared minus 3x over 3x squared plus 3x minus 6. And we're going to, let me rewrite this real quick. We can write this as x plus 1 all over 3. So now we're going to have 3 over x plus 1. We're going to be multiplying that right there. With this 3 here, everything would divide out with the 3 that we could kind of factor out here. So all those 3's are gone, and this x gets multiplied into all of those. But remember, we only care about the highest exponent. So this 3 is going to divide out. We have an x cubed in the numerator. That 3 is gone. So x times x squared also gets me x cubed. And the limit of this function of f of x over g of x as x approaches infinity is now, looking at the coefficients, 1 over 1 is 1. Moving on to question 2, free response. We have many things to be looking at. We know that f is the function given by ax plus b over x squared minus c. And it has these following properties. The graph of f is symmetric with respect to the y-axis. The limit of f of x as x approaches 2 from the right is infinity. And f of 1 equals -3. Okay? All right, so the first piece of information is that the graph is symmetric with respect to the y-axis. So that means that this is even. And with even functions, we know that f of -x equals f of x. So we want to be able to get back to the same thing. So if I substitute -x into our function, we have a times -x plus b over x squared minus c. So -x squared minus c. And if we simplify this a little bit, we're going to have -ax plus b over x squared minus c. And we want to compare, okay, what is the exact same? So I have a -ax plus b, and here we want it to say positive ax plus b. But my denominator came out to be the exact same. So the only value of a that'll make this numerator the exact same is a must be 0. So what I'm thinking here, if a is 0, then we're going to say 0, negative 0, or 0 times negative 1 times x, we're getting positive b in the numerator over x squared minus c. And then if a is 0 in the original function, 0 times x would be 0, 0 plus b would give me b, just a b in the numerator. So a can only be 0 in this case. Now with the second piece of information, the limit of f of x as x approaches 2 from the right side, well, let's see. It's going to infinity, 2 from the right side. So if we know we have b now over x squared minus c, and we know x is approaching 2, so 2 squared minus c should equal 0. So 4 minus c equals 0, so c has to be 4. So we know now a is equal to 0 and 4 is equal to c. And lastly, we want to know what is b. Well, since we're going to take this last piece of information, now f of 1 equals negative 3, we're going to say, all right, now we have b over x squared minus 4, and that's going to say, all right, so this is f of x from the pieces of information that we know. So we know that this is negative 3 when x is 1. Now we just need to solve for b. So we have 1 squared minus 4, that's negative 3. So we're going to multiply negative 3 on both sides. We're going to get positive 9 equal to b. So here we've solved for a, c, and b. So now using the answer from our last piece of information, we have this equation, f of x equal to 9 over x squared minus 4, substituting in the values for a, b, and c. So write an equation for each vertical and each horizontal asymptote. Let's start with the vertical asymptote, where our denominator is going to be 0. So x squared minus 4 equals 0. Add 4, so x squared equals 4. And take the square root of both sides. Don't forget, whenever you take a square root, you get a positive and a negative answer. So positive and negative 2. So for our vertical asymptotes, that's going to be x equal to 2 and x equal to negative 2. What we've done here by setting our denominator equal to 0, this piece is justification for our answer. And now for our horizontal asymptote, we want to see the limit of f of x as x approaches infinity. Well, since the degree of the numerator is less than the degree of the denominator, this is just going to be equal to 0. And that is, actually we also need to check our asymptote on the left side, negative infinity. But when I have negative infinity squared, it's not really going to matter. It's still going to be 9 over a really large number minus 4, so it's also going to be 0. So the equation for my horizontal asymptote is just y equal to 0. And then writing out those limits is justification enough. And now sketching out the graph that we have, well, we know that it is approaching 0, and we have asymptotes here at negative 2 and positive 2. We also know that the graph is symmetric, and we also know that f of 1 is equal to negative 3, and the limit of f of x as x approaches 2 from the right is infinity. So let's see. Oh, f of 1 is negative 3. So negative 3. So here is, let's just say that's 1 and 1, negative 1, negative 2, negative 3. We know that. We know this piece from the right side is going to infinity. So from infinity down to 0, because that's our horizontal asymptote. We know it has to be symmetric, so I can just kind of do the exact same thing over on the left side. Let me actually just put some vertical asymptotes in right now. Now we want to see what's happening in the middle. So since I also know that this 1 is -3, we also know that -1 is also -3. And since everything has to be symmetric, what we can do is just connect the points almost. And that is going to be our graph. So that is going to be our graph from the information that we were given and all the numbers that we got from before. Now that completes the free response walkthrough for the limits test review. If you have any questions, please don't hesitate to reach out to me and go back and check the multiple choice questions if you haven't already done so. Good luck on your test coming up. My name is Mr. Hernandez, and I'm always here to help.